Okay, good morning class. So today we're looking at trigonometry. At this point we have completed, we worked through the introduction of trigonometry. We said where it's been used, we said use in music, in digital imaging, we said they use it in drafting or architecture. It's also used in, often in engineering, what's this? Aircraft design and navigation. So the trigonometry is used in different industries. Okay. So then we went on and we went to prove that, not prove, but we were dealing with in exercise 5.1 was similar triangles. 5.2 we were dealing with the sine, cos and area. And now sine, cos and tan. Not so. So we said sine theta, cos theta, tan theta. Sine, cos theta. What does sine mean? It means nothing. What does cos mean? Nothing. What does tan mean? Nothing. Those things means nothing without an angle connected to it. Okay. So there need to be an angle connected, and if your angle lies here, we say that this is your opposite. Okay, this is your adjacent, and this is your hypotenuse. However, if that is your angle, that is your opposite, adjacent, and hypotenuse. Remember we said that. Then we also said that sine of theta, cos of theta, tan of theta is the same as odd over as a hat of apple. And some of you remember it as the other dirty rhymes, if you guys know. Yes?
So does this only occur in the right angle triangle?
Yes, that's important also to know that this can only be applied in right angle triangles. And in grade 11 we speak about non-right angle triangles. Okay, so that is still to come. But for grade 10, it's still happy days. We keep it all in the right angle triangles. Okay. What else can you do with the right angle triangles? Pythagoras, and the Pythagorean theorem says your hypotenuse squared equals, if this is your A, O, and H, we know that H squared equals O squared plus A squared, your Pythagorean theorem. Then we also spoke about labeling triangles, not so? So if that is your ABC, we also said that that's lowercase c, lowercase a, lowercase b. Not so? Alright. What else did we speak about so far?
The 90 minus.
Yeah, nice. Thank you, ma'am. I would have gotten that completely. She says that angle is 90 minus theta. Why? So angles in the triangle adds up to 180. So I could have said sine of 90 minus theta, cos 90 minus theta, tan 90 minus theta. What is the full name for cos? Cosine. Not cosec, cosine. Cosec, we're getting back to cosec. What is cosine? No? The full name for sine is sine, cosine, that is cos, and tangent is tan. Okay? But that is not important for now. Okay? Then we never ask you what is the full name for a mark what you use. But anyway, that's what it stands for. Now if you say sine is, so if you say sine is going to be that, your opposite, that would have been your opposite, if that is your angle. So, importantly, it depends on what angle you're looking at. So if you're looking at that angle, that is your opposite. If you're looking at B, then that is your opposite. Okay, your hypotenuse remains your hypotenuse. Why? So your hypotenuse is also always opposite the right angle. So at this point, we have finished 5.1 and 5.2. Okay. Now we're going on to the examples for 5. Let's read what they say here. Okay. I'm reading on page. What page is this on? We're reading from page 109. Okay, and this is let's keep the format the same. So this is grade 10. SS means the examples only. Trigonometry. Trigonometry examples for exercise 5.2, 3. And it's on page 110. The examples on page 109. The exercise on page 110. Okay, so let's do this. So let's read on what they're telling us here. So now we're looking at calculations in trigonometry. Find the ratio given the angle. People, what is the ratio? If you look here, these are ratios here. Can you see that? Those are ratios given the angle. A trigonometric ratio remains constant. What does constant mean? Say the same. Constant for each angle because the definition are based on similar triangles having the corresponding sides in proportion. We spoke about that when we did the exercise 5.1. Okay. It is possible to calculate the trigonometric ratios for every angle. Let's carry on here. Then we are told that before the invention of calculators and computers, trigonometric values were published in tables and had to be looked up for each angle. Okay, so which means to say, you used to have a log book or a trig book. Okay, then you would go and you go cos of 30, you find cos of 30 in the book, and you come to what the ratio is. Cos of 35, you come down the book and then, so they didn't have calculators or computers. Okay, so you guys must know about modern technology now. Okay. So these days we can quickly find them on the calculator, find the keys on the calculator. Look at the calculator, we sin cos 10. You all see this sin cos 10 in the calculator. Okay. Now on top of the calculator, let's pull my calculator up here. On top of the calculator, you will see, tell me what you see there. Your calculator, a D. Okay. Your calculator must have the D. The D means degrees. Okay. Because we are talking about an angle, and the angles that we are referring to, we talk about angles in degrees. No? When you go to university, they talk about angles in radians. Okay, which is R. I don't know whether they use G, which is gradients or grad. Okay, I haven't know where to down to that. But the D means degrees, R means radians, and the G means radians or grad. Okay. So your calculator has to be on degrees. If it's not in degrees, you're going to give you a different answer. You're going to give you an answer in radians or in gradients. Okay, grad. So if it's not in degrees, what do we do then? Or your calculator is acting up whatever, sending messages to somebody else. And what you do is, we press shift. Everybody do this, shift. Everybody, where's your calculator, my girl? You don't have a calculator?
I don't know.
Whose fault is that now? Calculations? Anybody else need a calculator for the speed? Come. Please do it back to me, no? Okay. So everybody have a calculator now. Right. So if your calculator is not in degrees, you don't throw it away, you put water on it. What we do is you press shift. Look there on top, you got the shift button. Everybody press shift. Now you see there's a 9 here. 9 is on top of 9 is clear. You see that's in yellow.
Yes, sir.
Now if you press shift, then that means you say you're activating all the yellow keys on the calculator. Okay. So you press shift, 9. So what does it say now? Clear. Okay, you're going to reset your calculator back to factory settings. Okay. So you say clear. We want to clear everything. Press equal for yes, and then AC for to agree. Okay, or to clear. You all got that, people? So press again. Press shift. Number 3, we're going to clear all. Press equals. Equal or AC. Yeah. Equals. Yeah, everything is clear. Can you see? So now your answer, the last answer calculated is gone. Everything's gone now on the calculator. So the calculator is back to normal, factory settings. Okay. So now your factory settings is, or your original setting is degrees. Okay. All right. These days we can quickly find them on the calculator. Find the keys in the calculator. So you all see sine, cos, tan in your calculator.
Yes.
All right. The sine, cos, and tan key function key are used to calculate the ratio values for the given angles. Okay. So let's carry on here. Example 1. An example is on page 109. It says use your calculator to determine a round answer of a round answer of where necessary. So now you put in your calculator. Sine, press in your calculator. Sine 30. You see this is degree on, this is degree. So am I going to put that to the power 0 in my calculator? No. Why? So the calculator already reads it as degrees. It makes sense. Now you put sine 30 degrees. What do you get? So sine of 30 is off. Let's go with B. Now you try B for me quickly. 2 cos 85. So you put for sine of 30, to show you sine of 30 equals a half. So now you do the next one. Right. So now we got 2 cos 85. Let's put that in the calculator. 2 cos 85. You can close the bracket if you like. And we're going to work to how many decimal places? 2. Okay. Always adhere to the question asked. Okay. If they say 2, then you give it in 2. If they say 3 or 1, you give it as the 1. If they don't specify, you have a choice. Okay. So that's going to give us an answer of 0, 1, 0. Okay. Now we got sine squared 50. What does that actually mean? Can I say sine, let's see here, sine squared. Can you see that they're squaring the angle and not the sine? Can you see that, people? And I can't get to square the sine. So what does that actually mean? Sine squared 50. That basically means sine 50 times sine 50. You all agree with that? Or it could have been written as sine 50 squared. Can you see that, people? It's actually sine 50 squared. So punch that in the calculator. Alright, so what do we get? So we put in the calculator, open brackets, sine 50, wait, that's not right. Open brackets, sine 50. I think it's cut off, looks like it. Right. Let's go again here. So that would simply be in the calculator sine 50 squared. That gives you 0, 5, 9. You all agree with that?
Yes.
Alright, 0, okay. Let's carry on. Is there D? Yes. Is there E? Yes. It's a loss. Okay, so now we're looking at D. This is 10, 60 plus 15. Put that in the calculator. Okay, so that's simply going to give us 10, 60 plus 15. Not so?
Yes.
Going to give me 2 root 3. But did I say simplify itself or decimal? Decimal. So I'm supposed to sign it decimal. So 3, 7, 2. Okay. 7, 3. Absolutely, 3, 3, 3. We will try the next one quickly. We got 10, 60 plus 10, 15. Well, don't waste your time. Eh? And you guys got it?
Yes, sir.
So that would simply be 10, 60, close brackets plus 10, 15 close brackets. Can you give us an answer? 2. So what they wanted you to actually see here is that 10, okay, they didn't say this, but I can see the reason why they gave it this is because 10 of 60 plus 15. Some of you would want to multiply the 10 out and get 10, 60, 10, 15. But what do you notice? The answers are different. So 10, 15 plus 10, 60 is never equal to 10, 60 plus 15 in brackets. You understand? So make a note here. Okay. Yeah, this is never the case. Okay. Put this here. Okay. So never we're going to multiply sine cos with 10 out like ever. Okay? Because sine cos and tans are functions. You can't multiply functions like that. Okay, there's other roots that comes into play. But for now, we're keeping it simple. We're going to play around with calculating this speed. Okay. So with that, I want you guys now to do exercise 5.3 on page 110. I'm on using your calculators, okay?